Alright, this video is on writing good scientific explanations using our oscillator model. And after watching this video, you should be able to write a good scientific explanation using our oscillator model. Now you have plenty of things in your binder that explain and describe our oscillator model and also good scientific explanations. Here is traits of a good scientific explanation. Starts with a thing that is having the influence, the independent variable usually, ends with a thing that is being influenced. Typically in our cases that will be the dependent variable. The explanation will use important related concepts from class, uses definitions and elaborations, creates a chain of logical links, usually 3 or more, and does not leave out any important links of logic. Now, what is our scientific model? Well, a scientific model is, like any scientific model, it's a set of ideas. In our case, it's a set of ideas about what affects the period of an oscillator. Now, our model includes certain ideas such as key concepts, things that affect the period directly, like inertia, centering force, and distance traveled. Inertia, centering force, and distance traveled. Now, our model also contains sub-ideas, things like things that can cause these key concepts to change. Things that can cause these key concepts to change. And then the third kind of idea our model includes is effects that these key concepts have on the period of an oscillator. Now, there's a lot of ideas here, and we can map them out in a more graphical way, as we have done in class, with some kind of concept map like this. Here's our main goal of our oscillator model, what affects the period of an oscillator. These are the key concepts, and then from there the things that affect the key concepts. We have, through our experiment knowledge, and in all of your handouts with experiments, you will be able to identify the kinds of effects that these have. Let's go ahead and try to use our oscillator model to make a prediction, an explanation. Alright, so let's do this one right here. Explain why increasing the mass on the inertia balance increases the period. We've seen that and talked about that many, many times. And here again are our traits of a good scientific explanation. I am going to minimize these so I have some room to write. Alright, we're going to start doing this in the usual shorthand symbolic form. Again, the good scientific explanation starts with the independent variable. So why does the mass? So we're going to say, well, an increase in mass causes, and now I can see from my chart here that it causes an increase in weight, but for the inertia balance, weight is not the centering force, and as a result, centering force will not be a factor that's affecting the period. Similarly, if I assume that I'm keeping everything else constant, then these things are not changing, and so they will not affect the period. Therefore, it must be the inertia that affects the period, and in fact, mass does affect inertia. So greater mass leads to greater inertia. If you want to read about inertia, don't forget handout 8 from Unit 1. Now, there's a logical link. Now we want to put an elaboration or a definition link in here. Greater inertia means a greater, and now we can put the definition in here, resistance to changes in motion. The inertia balance undergoes many changes in motion. It speeds up, it slows down, it stops, it turns around. Because it has a lot of inertia, it has a lot of resistance to changes in motion. Those resistance to change in motion make it harder to oscillate. And because it's harder to oscillate, it takes a longer time to oscillate, and I'll pick this up in the next segment.